Hello everyone, I'm Ms.R.Leethiyal, Assistant Professor, Department of Physics, Nirmala College for Women, Coimbatore. In this video, we are going to see about logic gates. Introduction. Logic gates are the building blocks of digital system. It is an electronic circuit which makes logical decisions. A logic gate accepts the input and operates on a required condition. If a certain condition is true, it turns on and goes off when condition is false. The most common logic gates used are OR, and NOT gate. The universal logic gates are NAND and NOR. Now we are going to see about OR gate. An OR gate has two or more than two inputs and one output signal. It is called an OR gate because the output signal will be high only if any or all input signals are high. From the truth table, it is clear that when the inputs of the OR gate are low, that is 0, the output will be 0. If any one of the inputs or both the inputs of the OR gate is 1, that is high, the output will be high, that is 1. An OR gate can be realized by PN junction diodes. D1 is the diode 1 and D2 is the diode 2. The negative terminals of two batteries are connected to the ground. When A and B are connected to 5 volt positive, they correspond to one state, and the current passes through the diodes, and in turns the current passes through the resistance. Hence, a potential drop is obtained across the resistance. This corresponds to state when A is connected to 5 volt and B is connected to 0 volt. The diode D1 conducts and the current passes through resistance. If A is connected to 0 volt and B is connected to 5 volt, the diode D2 conducts and the current passes through resistance. In both these cases, the current causes potential drop across the resistance R. This corresponds to one state. When both A and B are connected to 0 volt, both diodes will not conduct, and hence there will not be any potential drop across the resistance. This corresponds to 0 state. The Boolean expression corresponding to OR gate is Y is equal to A plus B. Next one, AND gate. The AND gate is a basic digital logic gate that implements logical conjunction from mathematical logic. It behaves according to the truth table. A high output 1 results only if all the inputs to the AND gate are high. If none or not all inputs to the AND gate are high, low output results. The function can be extended to any number of inputs. AND gate can be realized by PN junction diode. D1 is the diode 1, D2 is the second diode. The negative terminals of two batteries are connected to the ground. The resistor R is connected permanently to the positive terminal of the battery. Negative is connected to the ground. When A and B are connected to the negative, they correspond to 0 state. The current flows through the two diodes and the voltage drop across R is equal to the voltage drop across the diode. Hence, diodes now offer no resistance. The potential drop across the diodes is 0 in turn. The potential drop across the resistance is 0. This corresponds to 0 state. When A is connected to positive and B is connected to negative, or vice versa, one of the diodes conduct and hence the potential drop across the resistance is 0. When A and B are connected to positive, the diodes will not conduct and hence the potential drop across the resistance will be equal to the battery voltage. The Boolean expression corresponding to AND gate is Y is equal to A dot B. NOT gate. A logic gate which performs the function of logical operator NOT is called as NOT gate. Some of the function of NOT gates are as follow. It performs a basic logic function called inversion or complementation. The purpose of inverter is to change one logical level to opposite level. The gate has only one input and one output. This is the truth table. The bubble at the end of the NOT gate represents a signal inversion or complementation of the output signal. But in some cases, bubble are also present at the gate inputs to indicate an active low input. And the inversion of the input signal is not restricted up to NOT gate but also can be used on any digital circuit or gate. NOT gate can be realized by an NPN transistor. We choose RB and RC such that when 5 volt is applied to A, the transistor will be fully turned on, drawing maximum collector current. Hence, whole of the VCC is equal to 5 volt will drop across RC so that it will have 0 volt or low voltage corresponding to 0 state. When 0 volt is applied to A, the transistor will be cut off and there will not be any collector current and hence there will be not any potential drop across resistance RC. Now Y will have full voltage corresponding to one stage. Thus in each case output is the inverse of input. The Boolean expression corresponding to NOT gate is Y is equal to A complement. Here is the NAND gate. If the output of AND gate is connected to the input of NOT gate, then the combined circuit is called NAND gate. The combined circuit, the logic symbol and the truth table are shown. If the input 0, the output is the inversion of AND gate, that is 1. If all the inputs of the NAND gate is 1, the output will be 0. NOR gate. A NOR gate is a combination of OR gate and NOT gate. It has 2 or more input signal but only one output signal. All inputs will be high input. This is the truth table. Applications. Logic gates are used in circuits involving computation and processing. AND gates are used to enable or inhibit the data transfer function. NAND gates are used in burglar alarm and buzzers. They are also used in push buttons, which is example doorbell. They are used in the functioning of street lights. Advantages. Some of the advantages are: logical operations are performed using Boolean algebra, which makes the circuit design more economical and simple. Logic 1 and logic 0 can be easily distinguished. Disadvantages. Operating voltage is limited. Time delay occurs between input and output.
Thank you for watching this video. Happy learning.